There are several important operations with vectors in physics, and one of them is being able to add vectors. There are two ways to add vectors. You can either do it graphically, where you put them tail to tip, meaning the base tail of one vector to the tip of the other vector, and then you draw the line from one to the other, and that represents the sum of the vectors. I'll work out a numerical example, but really quickly what that means is if this is the first vector, then this is the second vector, and you want to add both of those, let's just call it v1 and v2 for now, then the sum goes from the tail of the first one to the tip of the second one. Whoops, I missed a little bit. Say I hit that right on. Then this vector is the v1 plus v2 vector. So you put them tail to tip, and then you draw the line from the tail of the first one to the tip of the second one. Actually, and you can do more than two at once, and that's why it says the last one. So if you just keep stacking them up, then you draw from the tail of the first one to the tip of the last one. That, if you need to get a numerical answer, you better have graph paper and or a protractor. So that's not always the best way to do it. You're probably going to end up doing it by components more often. So when you want to add two vectors by components, it says add like components. I'll show you how that works out. I really like using column vectors for this. This is an idea that I got from Ray Cruz. And so it looks like this. If you write all of the vectors in the equation as column vectors with the x component, you do have to be careful to keep all the x components on top and all the y components on the bottom. So ax and ay, bx and by. The cool thing about using column vectors is that the rows then become equations in and of themselves. So when it says add like components, most people are probably going to immediately write down cx equals ax plus bx. And that's very true, but it's very easy, it's nice and easy to see when you write it this way. Similarly, the y components are also a row in themselves, and you can add up the rows. So column vectors work because you can, it's a very visual way. You can see the sum. It's vector c plus vector a plus vector b. I'm sorry, c equals vector a plus vector b. And then cy equals ay plus by, which corresponds exactly to the bottom row when you write it as a column vector.